Hey everybody, this is Mr. Munson. We are continuing in Unit 8, Quadrilaterals, and in this video is Concept 3, 8.3 Parallelograms in the Coordinate Plane. This video is dedicated to Brooklyn in my second period who loves boneless buffalo wings. Just look at that plate of perfection. Feel free to put the video on pause and just stare at that yummy food. Otherwise, let's get started.
All right, so these three formulas are going to be our main tools for working in this section. So go ahead and put me on pause. See if you can write down the formulas for these things without looking at your blue formula sheet. But if you need to, go back and look at those. Go ahead and put me on pause and see if you can do it on your own. Okay, so for the distance formula, we should, given 2 points, and you try and find the distance between those 2 points, you take your x's and subtract them, and your y's and subtract them, and then you square them, and you take the square root of that whole thing. A lot of times students forget to take the square root of the whole thing to find the final distance, okay? Slope is the change in y on top over the change in x on the bottom. And then for the midpoint, we're going to add together your x's and divide by 2 and take your y's and add them together. And basically, we're averaging the x's to find the mid x, and we're averaging the y's to find the mid y. Okay, so on these problems, there's a bit of being able to look at it and tell this is probably a parallelogram, but that won't suffice in giving you credit. So what I want you to do is make sure that you're paying close attention to the best practices, right? So we definitely know this is a quadrilateral. What we want to do is see if there's enough information to move it from just being a regular quadrilateral. Let me fix my diagram. Here we go. Just being a regular quadrilateral, and see if we can move it into being, in this case, parallelogram. And then once we know it's a parallelogram, can we move it into being a rhombus, a rectangle, and then possibly even a square? Okay? So this is how I go about doing it. Now we have these three tools that those formulas that we had at the beginning. And so what we want to do is use those three tools to kind of find out characteristics about the shape that we're dealing with to see if it's a parallelogram, rhombus, or rectangle. I always like working with slope. It's much easier than the other two formulas for me. And so once I use slope, I can hopefully move that into being a parallelogram. And so if the opposite slopes are the same, that means that they're parallel. And the other thing is that if the slopes are opposite reciprocals, not only will that tell me it's a parallelogram, but it might move me into being a rectangle. And so it kind of kills two birds with one stone. So my first step whenever I'm trying to discover what kind of shape this thing is I go after slope. Okay, so why don't you go ahead and find each point's coordinates, and then go ahead and find the slope for each side. Put me on pause and go ahead and do that on your own. All right, welcome back. There's my point. So before I even start finding slope, you might want to confirm that you and I have the same points. That way, if we don't, then our slopes are going to be different. Okay, so if you take a look at my slopes, what we find is the opposite sides, like AB and CD, are opposite sides to each other, and they have the same slope. So that tells me that AB, if you look at the drawing, I'm going to put in my little parallel indicators there. Those two are parallel. And then, of course, with the other set, we can see that they're parallel. So we'll go ahead and mark them in there. So at this point, I know it's a parallelogram. So what I would know also is that since the two slopes right next to each other are not opposite reciprocals, right? So I'm comparing, let's say if you look over at the left drawing there, I'm comparing this AB with BC, this one right here, and they're not opposite reciprocals of each other, so I know that's not a right angle there. That disqualifies it from being a rectangle. This is one of the reasons why I like working with slopes, is because we can check so many things so quickly with just some simple calculations, right? Okay, so now we need to check to see if it's a rhombus. Now to do a rhombus, one of the things I do is check just to see if two adjacent sides, two sides next door to each other, are congruent, and that's going to be a distance formula problem. So let me take this information and downsize it so that I have more work room. So what I'm going to do is I'm going to use my distance formula, and I'm going to choose two sides that are right next door to each other to see if they're the same length. If they fail, then there's no chance it's a rhombus, because remember, it's not that the opposite sides are congruent. We already know that it's going to be true because we just proved it's a parallelogram. So now what we want to do is prove if it's a rhombus. We've disqualified rectangle because of the slopes. So let's do that. All right, so just for clarity, as I said two sides that are next to each other, I'm going to use these 2 points to create the side AB. Then I'll go and do, let's say, AD as a side next to it, or BC, which is a side next to the previous one. That's what I'm going to do. So right now I just found that AB was equal to 5. Now let's go find BC. All right, so you go and find BC, and then come back and check your work with me. All right, so I got square root of 40. I'm not even going to turn that into a decimal or anything. I know that the square root of 25 and the square root of 40 are two different numbers. Okay, so I just found, if you look over the left-hand drawing there, I just found that this side right here and this side right here are two different lengths. That disqualifies it from being a rhombus. Cool? All right, now just as a reminder, too many of you are dropping your square root symbol, and so when you get down here, you just have 25. At this point in the game, you're now being silly, okay? So we need to go ahead and stop doing that and making sure you carry your square root symbol throughout, and then take the square root of whatever the final answer is there, okay? All right, so let's move on. We just, I'm sorry, what we've done is we checked off that it's a parallelogram. It failed because the opposite reciprocal slopes didn't pan out for us to be a rectangle, and the sides didn't pan out. So we conclude this is a parallelogram, and then we'll write a short reason why. Opposite sides are parallel. Okay? All right, let's move on to another one. So for me, I pretty much attack these the same way every single time, okay? So I'll look at it and say, okay, let's see, first of all, it's quadrilateral, 4 sides. Let's prove if it's a parallelogram. So let's do the slopes, and then once I know it's a parallelogram, I can look at the slopes to determine if it's a rectangle, and then I'll look at the side lengths of two of the adjacent sides, see if it's a rhombus, and if it satisfies both those things, then we get to conclude it's a square. So what I want you to do is go ahead and do this one on your own. So you're going to do the first step, find the slopes. Compare them to see if it's a parallelogram. Second thing, see if the slopes are opposite reciprocal for a rectangle. And then third, check the side lengths to see if they're congruent for a rhombus. All right, put me on pause and go ahead and do that on your own. Now certainly there's a couple of different ways we can find slope, especially if the coordinate plane is sitting there right in front of us, right? So we could use the distance or the midpoint form, the slope formula like we did before in the previous problem, or we could just simply look at going from a point to another point. So I went up 1 and to the left 3, so that's a -3. So that's how I created that slope, right? And so I can do the same thing for all the other slopes to figure out what they are. Okay, well, the way I arrange it as well is sometimes helpful. So if you look at AB in my problem here, BC is the one that's right next door to it. So, and then AB and CD, they're opposite of each other. So it just makes it easier for me to kind of organize if I do it this way, right? So what I find is that AB is -1/3 and CD is -1/3. So far I have one set of parallel sides. And of course I look at the other sides, they're opposites, and they are parallel. So right now I have a parallelogram, that's for sure. Okay, now we go up and look at the opposite reciprocal to see if we can determine if they're rectangles. All right, so opposite reciprocals, just by the way I've arranged it, that one and that one are two adjacent sides. And so one's -1/3 and the other one's a +3/1. Those are opposite reciprocals. I don't need to check anything more. Since it's already a parallelogram, I just confirmed that AB is perpendicular to BC. And once you get one right angle into a parallelogram, they all become right angles. So right now, we know this thing's a rectangle. So we'll just say it's a rectangle, right? All right, so let's check to see if it's a rhombus. And to do that, I'm going to use the distance formula. So I'm just going to use the distance formula to find a couple of sides. Let's say it doesn't matter which side, so I'll choose A and AB and then side AD, and just see if those two adjacent sides are the same. If they are, then all the sides become congruent. That's because it's a parallelogram. If this one's congruent to this one, we already know because it's a parallelogram that it's going to be congruent to this side. Going this way, opposite sides are congruent, and then this way, right? So that's plenty of information for us to do it. Okay, let's do distance formula. Go ahead and put me on pause and do this one on your own. Make sure you're getting plenty of practice using the distance formula. And there you have it. Now, notice I didn't use my calculator to figure out, if you need to use your calculator to square stuff, you go right ahead. But notice I didn't take the square root of 10 and turn to decimal. I just wanted to see if these ended up being the exact same numbers. And they are. So that what's that saying is that this side and this side are the same. Now, that's very predictable if you think about it, because this triangle right here, which is a 3 and a 1, is exactly the same triangle. It's a right triangle in both cases as that 3 and 1. So the hypotenuse is going to be the same. So that was definitely predictable. Now there's another way that we can determine if it's a rhombus, and that is, first of all, since we know it's a parallelogram, if the diagonals end up being perpendicular, right, then it's a rhombus. So we could actually use the slope formula to see if they are opposite reciprocal slopes. So if you prefer to work with slope instead of the distance formula, that's one of the things that you could do. I'm going to do that real quick just to show you how that works. So now we could use the formula, or since we have the grid right here, we just simply use rise over run. Okay, so it goes up 4, -2. And so that is a slope of -2 over 1 once it's reduced. And then we look at the slope of BD, and that ends up being up 2 over 4, and or down. I'm sorry, down 2. I'm moving from B first, right? So it's down 2 to -4 to D, and that gets me a 1/2. Now I could have started at D and did the same thing, and it still ended up being positive. Okay, so if you look at these two slopes, they're opposite reciprocal, so we know this thing's now a not rhombus or a rectangle, but a rhombus because the diagonals are perpendicular. All right, very good. All right, so now just even looking at this one, we can kind of tell it's probably going to turn out to be a rectangle. So let's go ahead and have you walk through your steps and do this one on your own and see how you do. Just come back and check your work. Now, we haven't used the midpoint formula, but we could, if we wanted to use the midpoint formula, we could see if the diagonals bisect each other, right? If they bisect each other, then that forms two diagonals that bisect each other means that it's going to be a parallelogram. So instead of using slopes, we could use the midpoint formula to get the diagonals, to see if the diagonals bisect each other. Okay, very good. So let's actually go ahead and do it the way we've done, slopes, and then using either the distance formula or the slope formula to find out if it's a rhombus. Okay, welcome back. So parallelogram, opposite sides have the same slope. That means that they're parallel. All right, so we're in the parallelogram category. Let's go to rectangle. Okay, adjacent sides are opposite reciprocals, right? So these two here, if you look at that, once I have, since it's a parallelogram, once I have one set of sides, adjacent sides that are opposite reciprocals, that makes that a 90. That means they all become 90s, right? Okay. Now, if I walked up to a quadrilateral and checked one set, it's just a regular old everyday quadrilateral. If I checked just two sides to see if it's a rectangle, you know, they're opposite reciprocals, that would not imply that it's actually a rectangle. Here's a good example, a picture of one quadrilateral where you might find a right angle someplace but not in the other sides, okay? So you have to start with that it's a parallelogram. Then once you get one right in there, then they all start becoming rights, okay? So let's make sure we're doing it in the correct order. Now for me, so, I get to judge for myself if I'm going to use the distance formula or the slope formula. I can use the distance formula on its sides to determine if they're the same length. Now I can tell that right away they're not going to be, not just because of the way they look, but if you look at the triangles, this triangle here has a side of, I think it's 8 by 2. This triangle up here has a side of 4 by 1. There's no way that the hypotenuse on a 4 by 1 triangle is going to be the same size as as an 8 by 2. It's just not going to work out. It's going to be way bigger, okay? So, but we always have to show our work. I like to do slopes, so I'm going to do slope real quick of the two diagonals. So I just counted the slopes for that. And so the blue slope is a 7, 6, and the other slope, whoops, I forgot my negative on the blue one. All right, so the diagonals are definitely not opposite reciprocals, so they're not perpendicular. So it fails the rhombus test. Remember, I can use the distance formula on the sides or the slope formula on its diagonals to figure out if it's a rhombus. Since it failed the rhombus, it's not all it is a rectangle. Okay, so I'm going to state that it's a rectangle. It's the reason why is because it's a parallelogram with sides that are perpendicular, okay? All right, well, that's it. All right, that's it. Go ahead and draw your line, write your summary, and go ahead and do these do-it problems. They should be pretty quick, straightforward for you. I'll scroll through here so you can see the bottom problem. Whoops. Get that out of the way. Yike. All right, sorry about that. Let me finish scrolling it up for you. So there's a bonus down at the far right-hand corner. Okay? Good luck to everybody. See you next time.